here's what I did. I got a little candle and a mask and some sellotape. You then want to tape the two string ends of the mask to the candle, just like this. Then what you want to do is you just want to spread out the mask into an umbrella shape, all right? And now I'm going to light the candle. So I'll take my lighter and I'm simply going to light the candle wick, hold the mask over the flame, just like so. And as it collects the hot air, you're going to see it's going to start to float. And this works exactly the same way a hot air balloon does, where the hot air is less dense than normal air, causing it to float. So if I simply just blow out the candle, you see it just falls straight to the...
At first sight, there is nothing special in this video. We all are familiar with the hot air balloons, which operates on the same principle. Namely, there is a so-called envelope, which is in our case balloon itself, and a gondola, which includes a burner. The burner heats the air which flows into envelope, and the hot air inside of envelope has a density which is smaller than the density of the air outside of envelope. Because of this, the buoyant force which acts on the envelope can be greater than the net weight of this system, and for this reason, the balloon can fly. In the case of the mask, the roll of envelope plays mask itself, and the roll of gondola plays candle with a flame. Again, the density of air under the mask is less than the density of air outside, and buoyant force can be greater than net weight, like here, and the mask can fly. So, one can see no reason why the mask cannot fly. However, I am sure that the video is a fake. The intuitive reason for such statement is that the buoyant force is proportional to the volume of envelope, and for the mask, this volume is too small to provide the large enough buoyant force. Of course, this statement must be confirmed by calculations. And here, I encourage you to do this calculation yourself and to prove or to reject my statement. If you are curious in the answer but don't want to do calculations, you can watch the video with the solution, and the link to this video you can find in description or in the pinned comment to this video. For those who want to do calculations on their own, here is some helpful information. In this table, you can find the density of the air as function of temperature for 3 temperatures. The mass of candle you can take equal 10 grams, and mass of mask is about 3 grams. More information about hot air balloon you can find on this site, and the link you can find also in the description. My advice is to estimate first volume of the envelope to calculate the buoyant force. Probably this is the most difficult part of the problem. Here envelope, of course, is the volume under the mask. And one more advice. The general rules for such estimations is to overestimate parameters which increase buoyant force and decrease the weight of the system. To follow this strategy, I would like to advise you to select the larger temperature than realistic temperature and to overestimate the volume. If the artificially increased buoyant force will not be able to lift artificially decreased weight of the system, this will be definite answer to the problem. So the video which we watched is a fake.